Hello everyone! In times where you find yourself without a car to go to the grocery store or without a bicycle, taxi, or any form of transportation, you could always get on your horse and go to the supermarket. Where there's a will, there's a way. Welcome to day number 23, Properties of Exponents. So for today, for this assignment, your first page will look like this, and you'll have 4 blue boxes with 4 solutions. You'll have to solve them and then just drag them over to the appropriate box. So let's see what that would look like. Well, the first thing that I want to go over with you is what would an exponent look like? Well, here you have a squared, or a to the second power. A is called your base, and the exponent, the 2, is called your exponent, okay? Here you have 4 cubed. 4 is your base, and your cube, or to the third power, is your exponent, okay? So just remember that. All right, so on the first page, you may get some problems that look like this. So I just want to go over some of the rules for properties of exponents with you. So in this problem, we have a squared times a to the 5th power. So the rule says that when you multiply exponents with the same base, keep the base and add the exponents. So our base is a, we're going to keep it, and we're going to add the exponents. So 2 plus 5 is 7, so my answer is a to the 7th power. Over here we have an exponent, a to the 34th power divided by a to the 4th power. The rule says that when we divide exponents with the same base, keep the base and subtract the exponents. So we're going to keep the base, a, and we're going to subtract the exponents. So a, 34 take away 4 is 30. So our answer is a to the 30th power. Here we're going to multiply a to the 4th power in parentheses times the power of 2. So how do we do that? Because over here we only have one base. So this is called the power to power rule. When you have one base with an exponent inside the parentheses raised to an outside exponent, you keep the base and multiply the exponent. So here you have a, keep the base, and 4 times 2 is 8. So your answer would be a to the 8th power, okay? On that same page, you may have some problems that look like this. So let's solve this together. You have a to the 2nd power times the 3rd power. Well, over here you have one base, which is a, and 2 times 3 is 6 times a to the 4th power. So now you have the same base, a times a. We are going to keep our a and add our exponent. So 6 plus 4 is 10. And our answer is a to the 10th power. So here we have a numerator and a denominator. So let's go ahead and do our numerator first. So we have a to the 4th power raised to the 3rd power. So that's a. 4 times 3 is 12. Let's just bring this over. And now we have the same base, which is a. We'll keep it. And since it's division, we will subtract 12, take away 7. Okay? And our answer here will be a to the 5th power. Okay? Because we're subtracting. Okay. So again, we have a numerator and a denominator. Let's take care of the numerator first. We have a to the 3rd power times a to the 3rd power. Same base, so we keep it. And we add our exponents. 3 plus 3 is 6. And let's bring over our denominator. Now we have a to the 6th power divided by a to the 2nd power. So when we divide exponents with the same base, we keep the base a and we subtract. 6 take away 2 is 4. Okay? The last one that you might have is a to the 4th power times the 2nd power times a to the 5th power. So let's do the top. A, keep the base. 4 times 2 is 8 times a to the 5th power over a to the 9th power. Again, we want to go ahead and simplify the numerator. So we'll say a, same base. 8 plus 5 is 13. Okay, over a to the 9th power. Now we're dividing, same base, so we will keep it a, and then we'll subtract. 13 take away 9 is 4, okay? And that would be our answer, all right? All right, so that takes care of that page. I know that was a lot of information, but you can go ahead and rewatch this if you'd like. So over here, you have a bunch of problems, 1 to 5, and you have to draw a line to what you think the second step would be and draw a line to what you think your solution would be. So let's go over some problems that will look like that page. All right. Let's see here. We have 3 cubed times 3 squared. So we're going to keep the base 3, and then 3 plus 2 is 3 to the 5th power. Well, what does 3 to the 5th power mean? It means 3 times 3 times 3 times 3 times 3. So if you figure that out, 3 times 3 is 9, times 3 is 27, times 3 is 81, and times 3 again, your final answer would be 243. So over here you have 3, keep the base, and then since it's a power to a power, 3 times 2 is 6, and that again means 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, okay? 3 times 3 is 9, times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. And then 243 times 3 is 729. Okay, here we have 3 to the 9th power divided by 3 to the 4th. So we keep the base the same. Since we're dividing, we say 9 take away 4 is 5. And again, that's 3 times 3 times 3 times 3 times 3, which we already figured out up here is 243, okay? So here we have 3 squared raised to a power of 2 times 3 to the 3rd power. So that's 3, 2 times 2 is 4, times 3 times 3, okay? 3 to the 3rd power, I'm sorry, keep the base the same. 4 plus 3 is 7, and that basically means 3 times 3 times 3 times 3 times 3 times 3 times 3. And we know 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729, and finally 729 times 3 is 2,187, okay? This problem here we have on top, our numerator, 3 squared times 3 to the 4th power, 3, 2 plus 4 is 6, over 3 to the 5th power. Since we're dividing, we're going to keep our base the same. 6 take away 5 is 1, and 3 to the 1st power is 3, okay? All right. Now the last page here, actually, yeah, this page right here, you'll go ahead and have to solve this, and whatever you think X is, your solutions are here. You will drag these blue boxes to each of these white boxes here when you solve this on scrap paper, okay? All right, so let's go over some sample problems. One of the things I want to show you is you may have a problem with a negative exponent. So here you have 4 to the negative 2nd power. You need to change that to a positive exponent. To change it to a positive exponent, you create a fraction line, put a 1 on top, and bring this to the bottom. When you bring it to the bottom, you make your negative exponent positive. And that's how you do it, Okay, over here, again, to make it positive, you make a fraction line, put a 1 on top, and then bring this to the bottom, and your exponent of -3 becomes positive. Over here, let's solve this problem. We have r to the second divided by r to the fifth, keep the base the same. 2 take away 5 equals r to the -3. And to make that positive, make a fraction line, 1 on top, bring your r to the bottom, and make your -3 positive. And that would be your answer, okay? So let's go over some sample problems that you may find. Over here you have a to the second power times the eighth is a. 2 times 8 is 16. Well, if you have a 4 here, 4 times what number would give you 16? Well, if you did a to the fourth times 4, you would get 16. So x equals 4 in that case, okay? Over here you have 3 b to the third times b to the fourth. Keep the base b. 3 plus 4 is 7. Equals b to the 15th over b to, well, we need to say 15 take away what number would give us 7? Well, if we did 15 take away 8, that would give us 7, so x equals 8. Over here you have c to the 6th times c to the second, so that's c. 6 plus 2 is 8. And over here you have 6 to the 5th times c. What number over here would give us 8? Well, 5 plus 3 would give us 8, so x equals 3. Okay, over here you have d to the 12th divided by d to the third, so that would be d. 12 take away 3 is 9. And then what number, 11 take away what number would give you 9? Well, 11 take away 2 would give you 9. So in this case, x equals 2. Okay, so here let's look at this problem. We have e to the -9 equals e to the 1 over e to the x. Well, that just means e to the -9, to make it positive, we make a fraction line, put a 1 on top, and make our -9. So x equals 9. And the last problem here, we have f to the third power divided by f to the fifth power. So we would say f3 take away 5 is -2. And how would we make that positive? We would make a fraction line, put 1 on top, and f to the second power. So x equals 2. Okay? I know it's a lot, so you may rewatch this several times if you need extra help. And then the last page here, you will have to look at both problems based on all of the examples and figure out who made the mistake, either Sasha or Mercedes in this case, and what was the mistake. Okay, so go ahead and take care of that, and I will see you tomorrow in day number 24. Bye-bye.